Halo semua, we are from Group 6 and this section we will present about computer science. Next. Okay, in this time we will discuss about control unit and then arithmetical logic unit and then memory data register and then memory address register and the last one is random access memory and read-only memory. I forget our group consists of Kenzi, Kiral, Kilam, Sabrina Guntara, and I, Tanya Oning Nurkinasi. Next. Okay, and those parts are in relationship in the commuter. So in this time, we will discuss about it. Next, please. The first one is control unit. The control unit is one part of the CPU was worked to provide direction or control over the operation format in the arithmetic logical unit section of the CPU. The output of this CU will regulate the activities of other parts of the CPU device. Next. Okay, what the function of the control unit? There are 6 functions of the control unit. The first is organize and control input and output device, and then retrieving instruction from the main memory, and then store the result of process to main memory, and then retrieve data from main memory if required by the process, and then send instruction to the although when there are arithmetic calculation or logical comparison and monitor works. And the last one is store the result of process to main memory. Next, please.
And then we talk about arithmetic logic unit. The arithmetic logic unit, or commonly called the ALU, is an important part of the central processing unit, or commonly called the CPU. ALU generally has a function to perform arithmetic and logical calculations. Examples of arithmetic operations are addition and subtraction operation. Logical operation are logical AND or NOR. In short, the ALU will not work if it does not get a command from the control unit in the processor and the vice versa. It will work when it gets a command. The control unit will give the command according to the command written on the register. After the ALU process is done, the result is a register, which contains the result of a calculation or some other command, or we can call a flag. And then what is main function and other function of ALU? The main function of ALU perform all arithmetic or mathematical calculations according to program instruction. And for the other function is make decisions from logical operations according to program instructions. And arithmetic logic unit using logical operations include the comparison of two logical elements using logical operators, namely first equals, second not equal to, and the third less than, and then less than or equal to, and then greater than, and for the last greater than or equal to. Just a picture of symbol of ALU. Next.
Okay, next is memory data register. So we will discuss what is MDR. MDR or memory data register, also called MBR or memory buffer register, is memory to accommodate data or instructions sent from main memory or accommodate data to be recorded to main memory resulting from CPU processing. The process of storing data into memory is done by indicating the memory locations where the data will be stored. Then the data to be stored is entered into the MDR to be delivered to that location. For example, the data will be stored at location 502 and 2 So the first thing to do is fill in the multi-purpose register R0 with the number 502. Move the contents of the versatile register R0 to MAR so that now MAR will point to memory location 502. Next, how to process read MDR or MBR from memory. First, put the memory address to be read. Second, send read signal via read control line. And third, decode the contents of the MAR so that the values of X and Y are obtained. And then four, put the contents of the designated address into MBR. And then how is the process of write MDR or MBR to memory? First, put the memory address to be written. Second, put the data to be written to the MBR. Third, send the write signal via the write control line. Fourth, decode the contents of the MAR so that the values of X and Y are obtained. Fifth, copy the contents of the MBR to memory. Next.
Okay, so now is the MER or memory address register. MER or register indicating memory address is a register that holds the address of data or instructions in memory to be accessed, whether it is to be retrieved or to be placed or stored or written. This register contains the address of the data which is connected to the address bus. Therefore, it can specify an address in memory for read or save or write operations. The address of the main memory is placed in the MER and then sent to the main memory via the address bus. While the computer is running, the address in the program counter is fetched on the MER. After that, MER will send the address into RAM and the read operation is executed. Next, MER functions as a component ordered by the IR and CUI or control unit to find and accommodate data addresses and instructions in a main memory. So the picture below is relation between MER and MBR.
Next, we're going to RAM or random access memory. All data and programs entered through the input device will be stored first in the main memory, especially in RAM, random access memory. RAM is memory that can be accessed, which can be filled and retrieved by the programmer. The structure of RAM is divided into four parts. First, input storage, used to accommodate input entered via input devices. And the second is program storage, used to store all program instructions to be processed. The third is working storage, used to store data to be processed and the results of processing. The fourth is output storage, used to accommodate the final result of data processing that will be displayed to the output device. Input that is entered through the input device is first accommodated in the input storage. If the input is in the form of a program, then it is transferred to program storage, and if it is in the form of data, it will be transferred to working storage. The results of the processing are also accommodated in the working storage, and the results that will be displayed are transferred to the output device and are moved to the output storage. Next, please. Next is ROM or read-only memory. ROM or read-only memory is memory that can only be read. Programmers cannot fill something into ROM. The contents of the ROM have been filled in by the manufacturer in the form of an operating system consisting of the main programs required by the computer system. Next. So the relationship between CPU, main memory, and I/O devices are the connection between the CPU and main memory or I/O device is carried out by a path called the bus. The connection between the CPU and main memory via the bus line is attached to the MDR, MAR, and control unit on the CPU. While the bus that connects the CPU to the I/O device is not placed directly into the I/O devices, but can be through an I/O port or DMA controller or I/O channel.
Okay, that's all from our group, and thank you for your attendance and happy for your next day. Thank you.